So, good morning, good afternoon, guys, wherever you are, and welcome to AI Governance Engineering with myself, Gavin. And today I'll be presenting on the relationship between the EU AI Act's data quality requirements and the technical standards that support compliance, specifically the harmonized standard, which has just recently been released, which is prEN or prEN 18286, and its relationship with the ISO 5259 series on data quality for artificial intelligence and machine learning. So this presentation examines how regulatory requirements flow from the EU AI Act through quality management system standards into concrete technical implementation methods. So I'm now going to go over to the slides. I'll see you soon. So let's begin with the regulatory foundation. Article 10 of the EU AI Act, titled Data and Data Governance, and this establishes the fundamental requirements for high-risk AI systems. So as it says, the regulation states, high-risk AI systems which make use of techniques involving the training of models with data shall be developed on the basis of training, validation, and testing data sets that meet the quality criteria referred to in paragraphs 2 to 5. So this is the starting point. The EU AI Act doesn't just say use good data, it mandates specific quality criteria. So if we just look at some of the bullet points, so Article 10 requires that training, validation, and testing data sets must be subject to appropriate data governance and management practices, relevant, sufficiently representative, and to the best extent possible, free of errors and complete. It should also be equipped with appropriate statistical properties, and it should be managed to mitigate possible biases that could affect health, safety, or fundamental rights. So just notice the language here. Shall be developed, must be subject to, shall have. These aren't just suggestions, these are actual legal obligations for providers of high-risk AI systems who are hoping to operate in the EU market. So if we look now at the recently released, I'm going to call it prEN. If we look at prEN 18286, this is just an overview. So how do organizations actually comply with Article 10? So this is where prEN essentially comes in. So prEN 18286 specifies the requirements and provides guidance for the definition, implementation, maintenance, and improvement of a quality management system for organizations that provide AI systems. So this is a harmonized standard, as we can see, meaning it's being prepared under a commission standardization request specifically to support the EU AI Act. The standardization request number is M/613. So what does harmonized mean in practice? It means that once this standard is cited in the official journal of the European Union, compliance with its requirements creates a presumption of conformity with the corresponding articles of the AI Act. So in other words, if you implement prEN 18286 correctly, you have a recognized pathway to demonstrate compliance with Article 17 of the EU AI Act, the article that requires providers to establish a quality management system. So now let's look at the specific connection between the AI Act and this new standard. So Article 17, paragraph 1, point F of the EU AI Act requires quality management systems to include systems and procedures for data management, and it lists 10 specific operations: data acquisition, collection, analysis, labeling, storage, filtration, mining, aggregation, retention, and any other operation regarding the data. So this is quite comprehensive. The regulation isn't leaving data management to chance. It's explicitly requiring documented systems and procedures for every stage of the data pipeline. So if we look at the implementation section in prEN 18286, prEN implements this through clause 8.5, which requires providers to put in place a strategy for data management compliance, define, document, and implement data management processes, and establish and maintain systems covering all these operations. So the standard translates the regulatory requirement into actionable quality management system components. So let's examine clause 8.5 in detail, because this is where kind of the rubber meets the road. So if we look here on the left-hand column, the standard requires systems and procedures for all 10 operations listed in the AI Act, from data acquisition through to retention, and no gaps are permitted. If your AI system involves training data, you must have documented procedures for how the data is acquired, collected, analyzed, labeled, stored, filtered, mined, aggregated, and retained. Now moving over to the right-hand column, doesn't just stop here. The standard also requires process documentation for data requirements. What do you actually need? Data planning, how will you obtain and manage it? Data preparation, how will you process it? And data decommissioning, what happens when it's no longer needed? And if we look at the bottom, and more critically, it states the provider shall specify a mechanism for data no longer in use is destroyed when each AI system is decommissioned. And this addresses the entire data life cycle from acquisition to destruction. This is quite comprehensive data governance. Now here's where it gets interesting. prEN 18286 tells you that you must have data management systems and procedures, but it doesn't tell you how to actually measure data quality or what specific characteristic to assess. So looking here at the quote from Annex B, the standard itself recognizes this. In Annex B it states, subclause 8.5 directly connects to two related standards, prEN 18283 and prEN 18284. These standards provide detailed technical specifications for data quality, and bias management can be implemented through quality management system. Think of these in this diagram here, this flow diagram, as three layers. You start with the EU AI Act Article 10, which establishes the high-level requirement you must use quality data. Then prEN 18286 Clause 8.5 operationalizes it. You must have documented systems and procedures for data management. ISO 5259 series provides the technical methods. Here's how to assess, measure and improve data quality. So this is the standards architecture. Each layer builds on the one above it, moving from regulatory requirement to technical implementation. So let me introduce you to the ISO 5259 series. So this is a family of 6 standards, 4 currently published and 2 under development. So the stated aim is clear: to provide tools and methods to assess and improve the quality of data used for analytics and machine learning. And if we look at part 1, it was published in 2024. It provides the overview, terminology and examples. Most importantly, it defines the data lifecycle model that structures the entire series. Over to part 2, which was also published in 2024, is where the measurement happens. It provides the data quality model, the specific data quality measures, and guidance on how to report data quality. Part 3 gives us the management requirements, how to establish, implement, maintain, and continually improve data quality as an organizational capability. And finally, part 4 provides the process framework, breaks down into different ML approaches: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning, and also general analytics. And each has specific data quality considerations. All 4 of these parts are published standards. They're available now and you can implement them today. So looking now at ISO 5259 parts 5 and 6, which are both actually still under development, but they're important to know about. So if we look at part 5, this will provide a data quality governance framework, and the scope is to enable the governing bodies of organizations to direct and oversee the implementation and operation of data quality measures, management and related processes. So this is the governance layer, how boards and executive teams oversee data quality programs. As of publication of the standards we're reviewing today, part 5 was at the draft international standard stage, ISO IEC DIS 5259 section 5 2023. Now if we look at part 6, this is a technical report on visualization, and its purpose is to enable stakeholders using visualization methods to access the results of data quality measures. Think dashboards, reporting tools, quality scorecards. Part 6 is about making data quality visible and understandable to non-technical stakeholders, and this was at committee draft stage, ISO IEC CDTR 52596 2023. Looking at the quote at the bottom, it notes this visualization framework supports data quality goals. So when these parts are finalized, we'll have a complete suite: measurement, management, governance and visualization. So let's dig into part 1 because it establishes the conceptual foundation for everything else. So part 1 states the data lifecycle for analytics and ML provides an end-to-end description of how data are used and additional data are generated within analytics or ML systems. This is important. It's not just about the data you start with. Machine learning systems generate data throughout their operation, and that data needs quality management too. So the data lifecycle includes these components: a data quality model, the set of characteristics you're assessing. Data quality measures the variables you assign values to throughout measurement. Data quality assessment, evaluating whether you meet requirements. Data quality improvement, processes to enhance quality when assessment reveals gaps. And data quality reporting, documentation of quality status for stakeholders. So these aren't isolated activities, they're integrated processes that operate continuously throughout the AI system lifecycle. Part 2 is where theory becomes practice. It defines what we actually mean by data quality. And if we look at the quote here, a data quality model is a defined set of data quality characteristics which provides a framework for specifying data quality requirements and evaluating data quality. Now, this is crucial. Quality isn't subjective. It's not good enough or pretty good. It's measured against specific characteristics that you define based on your use case. So looking here at the left-hand column, inherent data quality looks at the data itself. Does it have the intrinsic potential to satisfy your needs? This is independent of any particular system. It's about accuracy, completeness, consistency, and characteristics of the data as data. On the right-hand side, system-dependent data quality looks at how quality is reached and preserved within a computer system. This is about accessibility, efficiency, portability, characteristics that depend on your technical infrastructure. Now, both views are necessary. You can have inherently high quality data that's poorly managed in your systems, or well-managed systems working with inherently poor data. You need both. So part 2 builds on ISO IEC 25012, which established 15 data quality characteristics for general software engineering. So these 15 characteristics are divided into inherent and system-dependent categories. Inherent characteristics include accuracy, completeness, consistency, credibility, currentness, precision, traceability, and understandability. These describe what the data is. System-dependent characteristics include accessibility, compliance, confidentiality, efficiency, portability, and recoverability. These describe how the data is managed. But here's what makes ISO 52592 special. This document defines additional characteristics that can contribute to higher quality ML models and applications. Machine learning has unique data quality considerations that general software engineering doesn't address. What about balance in your training data? What about representativeness across different populations? What about the diversity of your examples? The standard recognizes this and extends the framework specifically for AI and ML contexts. And critically, it explicitly allows organizations to further extend the model. As we can see, organizations may design their own data quality model by extending the data quality characteristics and data quality measures to fit their data requirements. Part 3 shifts from what to measure to how to manage. So reading the quote, Part 3 specifies requirements and provides guidance for establishing, implementing, maintaining, and continually improving the quality for data used in the areas of analytics and ML. So this is a management system standard. It's about organizational capabilities, not just technical methods. As we can see here, the standard requires resource management. You need software applications, IT infrastructure, and personnel with the right skills. Data quality doesn't happen by accident. It requires investment. Documentation. Everything must be intelligible to relevant stakeholders, accessible and version controlled, and you need to be able to demonstrate what you've done. Audit and assessment. Periodic evaluation of whether your data quality plan aligns with organizational rules and actually achieves its objectives. Data specification. Explicit documentation of data format requirements, statistical properties, and the tools needed to work with the data. So these are organizational processes. They require governance, accountability, and continuous attention. So looking now at part 4. Part 4 gets specific about different types of machine learning and analytics. So looking at the quote, it provides general, common organizational approaches regardless of type, size, or nature of the applying organization to ensure data quality for training and evaluation in analytics and ML. So if we look at the coverage areas, notice the breakdown. Supervised ML with specific attention to data labeling, because labeling is where human judgment enters the process and quality can degrade. Unsupervised ML, where you don't have labels but still need quality data. Semi-supervised ML, combining both approaches. Reinforcement learning, where data is generated through interaction. And general analytics, for use cases that aren't necessarily training ML models. So each of these has different data quality considerations. The labeling requirements for supervised learning don't apply to unsupervised learning, and the data generation concerns in reinforcement learning are unique to that paradigm. Overall, Part 4 recognizes this diversity and provides tailored guidance for each. So let's talk about what happens when data quality assessment reveals problems, because it will. So looking at the opening quote, the results of data quality assessments often show that the data do not meet data quality requirements. In many cases, the data set can undergo improvement processes. Now, this is realistic. The standard doesn't assume you'll have perfect data. It assumes you'll have imperfect data and needs systematic methods to improve it. So looking now at the table on the left, Part 4 identifies 8 specific improvement processes. Transformation processes include cleaning, filtering, normalization, and standardization. These are about correcting or removing data that doesn't meet requirements. On the right-hand side, enhancement processes include scaling, imputation, augmentation, and encoding. These are about enriching or expanding your data set. Each process has specific use cases. Normalization helps when you have features with wildly different scales. Imputation helps when you have missing values. Augmentation helps when you don't have enough examples in certain categories. And so the standard provides guidance on when to use each technique and how to validate that it actually improved quality rather than introducing new problems. So let's step back and see the complete picture. At the regulatory level, we have the EU AI Act, specifically Article 10 on data and data governance requirements. Now, this is the law. This is what providers of high-risk AI systems must comply with. Moving down to the middle layer, the harmonized standard prEN 18286 translates these requirements into quality management system procedures. Article 17(1)(f) of the AI Act requires a quality management system. Clause 8.5 of prEN 18286 specifies exactly what data management procedures that QMS must include. And then we have the ISO 5259 series, 4 published standards providing the technical methods to actually implement data quality management. Part 1 gives us the framework and lifecycle model. Part 2 gives us the quality characteristics and measures. Part 3 gives us the management system requirements. And Part 4 gives us the process framework for different ML paradigms. Technical standards provide detailed implementation methods to achieve compliance with regulatory requirements through systematic quality management. Now, this is the value proposition. You're not guessing at compliance, you're actually following a structured, internationally recognized methodology. So how do you actually do this? Now, let me walk you through the 4-step implementation pathway. Step 1, identify requirements. You start by thoroughly reviewing EU AI Act Article 10 to understand what data quality requirements apply to your specific AI system. Not all requirements apply to all systems, and you review Article 17(1)(f) to understand your QMS obligations. Now, this is your regulatory baseline. Step 2, establish QMS framework. You implement prEN 18286 clause 8.5, and this means creating documented procedures for every data management operation: acquisition, collection, analysis, labeling, storage, filtration, mining aggregation, retention, and decommissioning. You're building the organizational structure. Step 3, apply technical methods. Now you implement the ISO 5259 series. You use Part 1 to structure your data lifecycle, Part 2 to select relevant quality characteristics and measures, Part 3 to establish management processes, and Part 4 to implement process frameworks appropriate to your ML paradigm. This is where measurement and improvement happens. Step 4, you demonstrate compliance. Step 4, demonstrate compliance. Throughout all of this, you're maintaining documented evidence. The technical documentation required by prEN 18286 clause 8.7, the data quality reports described in ISO 5259 version 2, the audit trails required by ISO 5259 version 3. All of this creates the evidence base you'll need for conformity assessment. This is a continuous cycle. You don't implement it once and walk away. It's continual improvement throughout the AI system life cycle. So let me summarize the 4 critical points from this presentation. First, the EU AI Act Article 10 establishes the high-level requirements for data quality in high-risk AI systems. These aren't guidelines or best practices. They're legal obligations with enforcement mechanisms. Second, prEN 18286, the harmonized standard, translates these regulatory requirements into structured quality management system requirements. Article 17 of the AI Act requires a QMS. Clause 8.5 of prEN 18286 specifies exactly what that QMS must include for data management. Third, the ISO 5259 series provides comprehensive technical methods and measures for implementation. It's not theoretical, it's 4 published standards you can implement today, with 2 more in development. And fourth, compliance requires integration across all 3 levels. You can't just implement the technical standards and ignore the QMS requirements, and you can't just document procedures without actual measurement and improvement. It's a fully coherent system, and here's why this matters. Once prEN 18286 is cited in the official journal of the European Union, compliance with its normative clauses confers presumption of conformity with corresponding essential requirements of the EU AI Act. Presumption of conformity is powerful. It shifts the burden. Instead of having to prove you meet the AI Act's requirements from scratch, you demonstrate that you've implemented the harmonized standard, and conformity is presumed unless proven otherwise. So before we close, let me give you the current status of all these documents, because timing matters for implementation planning. So the EU AI Act was published in June 2024. It's law. Certain provisions already in force, with full application coming in phases throughout the next sort of year or so. prEN 18286 is currently at the draft stage. Specifically, it's been submitted for CEN inquiry as of a few days ago, October 2025. And this is the consultation phase. Once comments are resolved and it's approved, it will be published as N18286 or EN18286. Then it gets cited in the official journal and presumption of conformity becomes available. The ISO 5259 series parts 1 through 4 are all published as of 2024, and you can purchase them from ISO today and begin implementation. Parts 5 and 6 are under preparation. Part 5 is at the draft international standard stage as of 2023, and part 6 is at the committee draft technical report stage, also from 2023. So these will take longer, but the core framework is already available. Now, this is a rapidly evolving standards landscape. What I've presented today is current as of the document date shown, but I'd recommend monitoring the official journal of the European Union for citation of prEN 18286, the ISO website for updates on part 5 and 6 of 5259, and CEN CLC JTC 21, the Joint Technical Committee developing AI standards for related work. So the core message is this: the EU AI Act sets some ambitious requirements for data quality, but providers don't have to figure out compliance from scratch. There's a structured standards pathway, prEN 18286 for quality management system implementation, and the ISO 5259 series for technical execution. This standards architecture moves from regulatory obligation to quality management to technical implementation in a coherent and internationally recognized framework. So I hope you all found this presentation insightful and helpful, and it's made some of you aware of the importance or usefulness of ISO 5259 series, as I do myself. The landscape for AI governance and requirements is changing by the week. It's truly mind-blowing, and it's important that we discuss this landscape, we create new ideas, new combinations, and just really stay on top of things here, and hopefully make life a bit easier for businesses trying to enter into this new space. So thanks again for listening. My name's Gavin here on the AI Governance Engineering YouTube channel. Please check out aigovernance-engineering.com, where I document my learning journey into AI governance specifically, but trying to sort of engineer it into sort of autonomous compliance for businesses and myself and my own practice. So thanks again, guys. I'll see you soon.